In Module 7 in the Applied Algebra 1 course, you really get into a detailed study of lines, linear equations, or equations in the form of lines, specifically slope-intercept form. Get to all that later. But we're also going to graph lines, and we're going to graph lines a lot. And it's not something that students tend to enjoy, but it's such a useful thing to be able to look at a picture of a graph that it's something you really need to learn how to do. You also need to learn, conversely, how to read a graph so that as consumers you're not always being duped by information that's presented pictorially. I think a lot of times people, advertisers, maybe even public officials, people who want to convey a concept or information to you might take advantage of the fact that you don't know exactly what you're looking at. So you really need to understand what you're looking at. I don't want that to happen to you. So let's look at a common thing we've been looking at throughout the course. This relationship, P equals 10h, that's actually a line. It's in linear form. It has two variables. It meets all the criteria for being a line, so it is a line. And this relationship refers to amount of pay we make, saying that, in fact, it means the amount of pay we make is equal to $10 for every hour we work. The h here is equal to hours. 10 represents the $10. That is the slope of our line. It's the slope of this relationship. So for every hour, the amount of money we have increases by $10. So it's an increasing or positive slope. So that's the equation. That's the linear form of the equation form of this line. This is the graph of that line, and I know this is a little bit hard to read because it's such a steep incline, but if you look at it, I can quickly tell where I'm at. The bottom line goes from the x-axis goes from 0 to 50, so each of these little increment lines is 10. So if I work 10 hours, I can look up here and see quickly that I have $100. I knew that already. 10 times 10 is 100, but this is just a way to look at it pictorially and how fast it can go up over time. So a useful tool. Not as useful in this case, but you'll see other scenarios where it is actually more useful. You could also use a graph. A lot of times it's used to estimate how much you're going to make. So if I could see far enough, I could see how much I'm going to make in 100 hours. Businesses use graphs a lot, graphical representations of their income and of their cost to see what it's going to cost them over an extended period of time. And they use it to make predictions and make good decisions about their businesses. Well, let's look at a really simple example of a linear relationship. And in this case, Sally, the person's salary, Sally, the object of this story, wants to communicate to people how much it's going to cost to get a portrait painted, and that's a linear relationship. She obviously we start at $50, so just for walking in the door, you're going to pay her $50. She may call that a consultation fee. It may just be, a lot of times they have a minimum. I mean, if it takes 10 minutes, it's still going to cost you $50. And then it goes up at a linear rate from there, so you can see over time, at the end of 1 hour, at the end of 2 hours, you're at about $100. So at the end of 1 hour, you're probably about at 75 or somewhere like that. Anyway, it gives you a visual representation of wherever you're at. 5 hours, you're approaching 200, not quite there yet, so somewhere in between. So that's just a simple example. An actual real-world example is this one. I'll get it into the view of a baby's growth. And these are linear relationships, and if you ever have a child in the future, you'll go to the doctor, you'll have a well-child checkup, and they'll show you where your baby's height is, or length in inches is the way they communicate it then, in relation to the average. And this line represents average baby growth over time. And in this case, we'll pretend this dot is where the couple found out that their baby, or the person found out that their baby's length is in inches over time. So at about 13 months or so, they're here hovering around 22 or something like that. And the main thing is that they're below the line. They're a little bit below average. And doctors use this to determine if they're far enough below average, then maybe we need to look at a potential health issue, maybe a potential nutrition issue. But anyway, I wanted to show you just a very real example of something that's very common in the real world that you'll probably eventually encounter someday.